So thank you very much for that introduction. Thank you for the invitation, and thank you for your time. Today, Linda and I are super proud to present our journey from APA with respect to handling large deliveries of aerial imagery and a novel approach from Esri that we've adopted with our presentation called APA's Game-Changing Approach to Imagery and a Revolutionary Approach to Pipeline Management. Before we reveal the solution, we'll take a look at what APA does, where these operations occur, in order to get an understanding of the scale of the company and the size of the aerial imagery data sets that are being generated each month. So, who is APA? APA is a leading energy infrastructure business listed on the ASX who own and manage a diverse portfolio of assets worth $26 billion. We currently have 1.4 million households and businesses connected to our network. Our main business activities include renewable energy generation via wind, solar farms, and in Queensland, South Australia and Western Australia, as well as gas storage and distribution and transportation across every state in Australia. We manage more than 15,000 kilometres of gas transmission pipelines across the country, as shown on the map. APA has obligations to our shareholders, our landholders, the community, and many authorities across Australia to ensure the protection of these nationally critical data sets. In 2022, these obligations led to APA to search for the optimal method for the protection of these assets and the environment and our stakeholders. We know that in order to protect, we must inspect, and many regulators across Australia require APA to monitor and report on our energy network every month. We also know that the most efficient way to traverse across Australia for these inspections is from the air. So, mid-2022, we introduced the National Aerial Surveillance Project as a risk management solution to ensure the safety of the community environment and infrastructure. Not only are these monthly patrols conducting a visual inspection of the network as needed to meet our regulators' requirements, APA has extended the project to capture several remote sensing data sets. And it's these that we'll have a look at over the next couple of slides. Each aerial patrol is conducted with only 2 people on board the plane. There's a pilot who for safety reasons does nothing other than fly the plane, and then sitting next to the pilot is the observer, who operates the sensors fixed to the plane and is on the lookout for potential risks or damage to APA infrastructure. There are 2 main imagery products that are captured during each patrol. The first delivery is an oblique image, when the observer discovers a risk to the integrity of or access to a pipeline or facility. These are called sightings and are captured by the digital SLR mounted on the side of the plane. The second deliverable is a strip map captured over the pipeline corridor and facilities, and these are captured by the aerial sensor, the aerial imagery camera, mounted on the other side of the plane as shown on the screen there. The addition of the strip mapping, the aerial photography, to the surveillance patrol is a relatively small overhead, yet it delivers the most valuable information that we get out of this patrol to APA. So the integrity risks that the observer is searching for when they're flying are things like vegetation and building encroachments inside the easements or the corridors, vehicles and earth-moving equipment that are close to or inside those corridors, and illegal dumping or fallen trees that are restricting the access. But they're also looking for erosion subsidence and leaks inside the pipeline, which will be evident as vegetation diebacks in the imagery. If an observed sighting is considered critical, it's called in directly from the plane to APA, and these are referred internally as Category A sightings. The non-critical sightings are reported back at the end of that day's patrol, and these are referred to Cat B sightings. Both Cat A and Cat B sightings are entered into our aerial surveillance GIS dataset at the end of each day, which triggers a workflow for APA to action and remove that risk to the infrastructure. As well as the sightings being delivered to APA daily, we also receive low resolution at 20 centimetres tiles back to APA, but at the end of the patrol for the coast, it's coming back to us as a orthomosaic data set at a 6 centimetre resolution. So it's important to iterate again that the strip maps are a small overhead, but they're a super valuable asset for APA to have. Since we started flying in mid-2022, we've now collected over 50 terabytes of 6 centimetre imagery. And it's these strip maps that have been collected that Linda and I are going to focus on for the rest of our presentation. Many of APA's teams benefit from having access to the strip imagery being collected for each month. For example, our operations and maintenance team, they use it for infrastructure layout and design. They use it for maintenance planning, such as mulching or slashing, as well as construction progress monitoring. Our environmental team, they also use the imagery. They use it for vegetation health monitoring, because not only are we capturing RGB imagery, we're also capturing in the near-infrared bands as well, and we do NDVI analysis in-house. And of course, our geospatial solutions team, that's APA's internal GIS team. We use it for base maps, for ad hoc mapping requests, and also feature extraction and change detection, which we'll cover off on a little bit later. Delivery of all this information to APA has been a massive game changer, but it didn't come without its own unique set of challenges. So before the project started, APA researched all the platforms and discovered that traditional aerial photography is the best solution for us, because we can fly under the clouds at a speed that allows us to capture the network every month. Handling very large imagery data sets, this each month generates 2 terabytes of 15,000 1-kilometre tiles, is by no means easy, and here's how we did it. So to store the imagery, we first looked towards the clouds, and APA selected an Australian-based data centre, so it met our security and data sovereignty requirements. So now that we've got the platform and the delivery channel sorted, the biggest challenge would lay ahead of us, and that was that it generates so much information. APA did not have the resources to process, host and serve that extra 15,000 1-kilometre tiles of imagery each month, so we reached out to Esri Australia for assistance. How did Esri fix our problem? They introduced us to Image Dedicated for mapping, analysing, serving imagery directly from the cloud. Our strip imagery is served out as dynamic web services, which is then consumed by dozens of in-house web maps and other software applications, and that reaches around 2,000 staff inside APA. This large amount of data is now effortlessly processed via automated workflows inside Image Dedicated. And now Linda will share with you further information on the Image Dedicated environment.
Thank you, Shane. Wow, that is a lot of imagery every month. The frequency, volume, and analysis requirements made APA's use case perfect for ArcGIS Image Dedicated. ArcGIS Image Dedicated is a managed SaaS that allows you to manage, serve, process, and analyze imagery or any raster dataset directly from your AWS or Azure blob storage. The beauty of it is you can keep your imagery where it is. Many organizations turn to ArcGIS Image Dedicated as they already have their imagery in cloud storage. They are also mandated to keep this imagery in specific regions, or they need to process imagery close to existing storage to reduce egress costs and enable scalability. There is also no infrastructure required. This eliminates the time it takes to build, set up, and manage infrastructure for ArcGIS users. From your own cloud storage, you can transform large imagery collections into tiled and dynamic services accessible to users from ArcGIS desktop, web, and mobile applications. It also makes the imagery ready to use. It streams intelligent tiled services that provide performance and retain pixel information, so users can perform analysis, set renderings, and enhance imagery by changing band combinations. It also delivers dynamic image services that provide server-side mosaicing and processing for rich analysis capabilities and performance over low bandwidths. Here you can see the ArcGIS Image Dedicated architecture in more detail. You can host all your imagery in your AWS or Azure, and Esri deploys an Image Dedicated machine right next to it. You can choose a fully dynamic imagery server, or you can choose to serve tiles, such as tile packages, scene level packages, and vector tile packages. Esri, not Esri Australia, manage and upgrade the machines. These upgrades are now performed with zero downtime. So, what if you have a really large imagery processing job? You might have your own cloud storage already serving images, but you have no means to generate a brand new cache. This is where the processing and analysis server comes in. It can be spun up next to your cloud storage, Mosaic datasets are built, and then we spin up many machines to process in parallel at scale. This significantly reduces processing time. As an example, a typical cache on ArcGIS Pro machine might take around 60 hours. If we were to run the same process in the processing and analysis machine, it's less than 3 hours. You simply pay for the machine uptime through image dedicated processor time. Image dedicated is an annual subscription model which covers license, infrastructure, and CPU costs. Back to you, Shane.
Thank you, Linda. As Linda mentioned, by having our imagery stored, processed, and served from the cloud, APA benefits from outsourced IT, such as instant hardware upgrades when needed, as well as Esri's continuous software development. By leveraging off the new processing and analysis server within Image Dedicated, APA has gained significant performance improvements over the last few months. Making new imagery datasets available to our users previously took multiple days, and now that's turned around in less than 24 hours. This allows APA to publish new imagery services within the month they are captured, and bringing significant operational efficiencies and reducing risks to the pipeline by getting the latest data out to the users in very, very little time. Now that we have our monthly serving processes streamlined, we're shifting our attention towards what other analysis is possible at this scale.
Future updates to Image Dedicated will also enable APA to run the processing and analysis server for automating, detecting, and identifying those Cat A and Cat B sightings along their pipeline. These highly scalable and efficient cloud servers will bring timely reporting of change detection through deep learning tools. Once you've published raster data with Image Dedicated, you can then extract useful information from those datasets as it streams intelligent services that retain pixel information. Within imagery analytics in ArcGIS, we support all of these functions, in particular, change detection. My colleagues today have already spoken about maximizing insights with GeoAI and pre-trained deep learning models. We've been testing this a bit further with APA to help with their next objective, being able to automate the identification of Cat A and Cat B sightings and being able to report across 15,000 kilometers of pipeline every month. To start this journey, we went back to ArcGIS Pro to create a pilot and a proof of concept. As you can see here, this is just one small stretch of the APA 15,000 kilometer pipeline. The first thing we did was to bring all these individual images together into a Mosaic dataset. Once we did this, we also analyzed the imagery to understand what we were working with. Shane has already spoken about how this imagery was captured with 4 bands. One of those bands is near infrared. This has a lot of value for APA for other use cases. But it made it a bit challenging when we started to look at the deep learning and change detection. Regardless of that, we thought we'll take the imagery, we'll test it out, and we'll run it against the TECT-SAM model that my colleague Chris and Frank spoke about earlier. As you can see, we didn't get a great result. So we thought, let's refine this process further. We tried a different model. There are so many models on ArcGIS Living Atlas to choose from. We then went into checking out the building footprint extraction model that was actually trained on Australian data. So we felt that this probably fit our use case better. As you can see, we got a better result, but still not quite there. So again, we went back to the source imagery. And what we did is we actually extracted the near-infrared band. And that's because we learned that the deep learning model was trained on just RGB. So we stripped that out and we forced it into RGB. We used the raster function extract bands that is part of the ArcGIS Pro package. We then trained it some more and actually used one of the deep learning training models to refine this model against APA's imagery in particular. And we got a much better result, as you can see on the screen. So let's talk about some metrics. This demo was done in ArcGIS Pro. To extract the bands is instant with raster function. to retrain the model against APA imagery took around 5 days. To run the retrained model across just a 3-kilometre test area took 30 minutes. So that's about 10 minutes per kilometre. If we were to extrapolate this out across 15,000 kilometres, you're looking at a 62-day reporting cycle, which doesn't quite meet the requirements. This is where Image Dedicated comes into play. By leveraging the processing and analysis server, data can be analysed on parallel machines in the cloud, scaling up only when you need it. The next step would be to run this at scale in the P&A. But early tests on the beta have indicated this can be reduced to just a few days reporting. And you also have consistent analysis. Big wins. Some other key lessons that we learned from working with GOI: always check the model parameters. What was it trained on and where? Data and features across the world can often be represented in different ways. That's why we ended up choosing the Australian model. We also learned that it was really good to check the confidence ratings on the accuracy of the outputs, just to ensure that you can rely on the results that you're getting.
Thank you. So we've just heard multiple processing benefits while using Image Dedicated, combined with the new analysis server. So I'll cover off on a few of the business benefits that APA has discovered by using this remote sense data with our aerial surveillance project. Objective data is delivered compared to subjective reports. So the industry standard for monitoring easements is still to have people on the back of a low-flying helicopter sitting in the back taking notes. By capturing remote sense data, we've now got quantitative data, and information that was previously reported as, say, bad erosion can now be quantified as 23 metres of exposed pipeline due to recent flooding. Previously, the reports would go into a PDF document typically and sit isolated in an isolated environment, not being merged in with the GIS data and contextual information. So by having that remote sense data, we ensure that every metre of the network is actually being analysed rather than just the big issues being discovered. And another important benefit that we've discovered is feature extraction and change detection. So running the strip map through the deep learning analysis, we can detect, extract and quantify changes in the vegetation cover within the corridor. If inspections are done manually, small incremental changes tend to go unnoticed. By extracting features and comparing back-to-back surveys, as well as the first to last survey, the changes are instantly identifiable. So I'd like to wrap up and actually just say thank you to Esri with that, because the way that we're processing the information now has truly changed the way that we manage pipelines at APA, and it wouldn't be possible without their support, their products, and now particularly with the processing and analysis server, that we can actually turn around information within the month that it's being delivered. The thing that we didn't want is for information to be delivered and not be distributed out to the organisation in time before the next delivery comes in. So we've actually achieved that, and it's working really well. So thank you very much for that.
Thank you. Thank you, Shane, and thank you, APA, and thank you to all of you for your time today. Again, you're welcome to come out and have chats with us at the kiosk. You're welcome to submit some feedback via the survey, and you're welcome to check this back online. Thank you.
Thank you.